then we'll make better ones.
Ow!
Make them out of steel and we'll weld them.
Yeah!
To the left.
The time for toys is over. Now we're going to design our own darts and forge them out of steel. We're going to learn about the science, technology, mechanical and aerospace engineering used to make our custom projectiles possible. Then put our darts to the test. The challenge is to build aerodynamically stable and effective projectiles. Our darts will consist of the 4 components shown. The tip, barrel, and shaft are all one piece of forged steel. The fins will be bent out of wire, welded on, then covered. Let's jump right in, fire up our steel, and forge our tip.
So how do we know when to take it out of the furnace?
So I got this really cool toy. It's a thermal gun, and it's maxed out. Can't go that high. I should have checked that first. All right, we're just gonna do a little straightening.
I think it was straighter before I started hammering it.
It probably was.
Now that the first part of our dart is complete, let's take a look at the rest of the design. Humans have been building and optimizing projectiles for thousands of years. The real key to their effectiveness is aerodynamic stability. Projectiles are stable when they tend to stay parallel with the direction of airflow they're flying through, as shown by these arrows. The angle a flying body makes with this airstream is known as the angle of attack, so we want this to stay as close to 0 as possible. If we can achieve that, our dart's tips will always be pointed forward and ready to penetrate our target. The last thing we want is our darts to have a mind of their own.
Which way to go? I don't know, but hey, went that away. Let's go.
To ensure stability, our design must control the location of our projectile's center of gravity and center of pressure. Imagine our dart as kind of a 3-dimensional weather vane, with its center of gravity both its balance and pivot point. We will mark the CG with this symbol. The center of pressure is the center of all aerodynamic forces acting on our projectile, shown by this symbol and force vector arrow. As long as our CG is in front of our center of pressure, our darts will always be stable. To make this happen, we need to design our tip to be small and heavy, while making our fins light and large. Our dart's design comes from following these aerodynamic principles, but sometimes it's good to get help from an expert.
It turns out that our cameraman is actually an aerospace engineer.
So this is actually not too far off. I think it was a little bit.
It's gonna work. All you have to say is that it was gonna work.
It's gonna work, but I just wanted to educate you.
Okay, yeah. Oh, I stand educated.
Yeah.
I stand before you, an educated man.
Okay.
Our next build steps involve first trimming down our round stock, then forging our shaft.
Forge some steel, man.
Forge steel.
I'm sure our forgings are all cool by now, so let's bring them over to this template and mark things out. This is the cut line for our rod stock, and this is where we should start forging our shaft with the air hammer once we've heated it in the furnace.
This is what we're gonna do next.
Hello.
Give me a kiss.
Next up is fabricating our fin frames out of this copper-coated steel welding wire, then welding them onto our shafts. Beck is the MIG expert,
Right back.
Right.
while I'll be welding on the TIG machine.
Weld off.
Weld off. I'm gonna use hot glue.
MIG stands for metal inert gas. The metal part of the acronym refers to the metal welding wire that feeds out of the gun when the trigger is pulled. The inert gas is argon on both MIG and TIG welding, and its job is to shield the weld from oxygen in the atmosphere, to stop it from reacting with the hot metal and contaminating the weld. When she pulls the trigger, argon flows from the nozzle along with the electrically charged wire. When this filler wire makes contact with the workpiece, an electric arc melts it into liquid metal, which flows in between the parts, heating them up and fusing them together.
Awesome.
TIG is a little bit different. The business end of a TIG welder is called the torch, and it's used in a similar way gas torches are.
I can spray electrons out of this.
Okay.
The big difference is the TIG torch heats the workpiece with a precise and highly controllable electric arc instead of flammable gases. Controlling this arc is done with a foot pedal, which simultaneously turns on the power and starts the flow of masking gas.
I don't know, man. He doesn't have to practice. We can just go right to it. Go for it. There you go. Damn. Yeah.
Our last step is applying our decal printed lightweight organic fiber reinforced composite pressure sensitive adhesive coated low density polyethylene omnidirectional fixation strips to provide aerodynamic stability.
All right, so you guys wanna throw these? You wanna throw them at stuff? Yeah.